Good morning students. Today we will discuss position time graph. The position time graph for uniform motion as well as non-uniform motion is shown here. For uniform motion the position time graph it will be a straight line, whereas for non-uniform motion the position time graph will be a curve as shown. As you all know that in uniform motion velocity is constant, whereas in non-uniform motion velocity is changing. Remember here the graph is between x and t because we are discussing motion in a straight line, that means one dimensional motion, and in one dimensional motion only x coordinate of the particle changes with time. Next topic which we have to discuss is average velocity. Average velocity is given by displacement upon time interval. The formula for it is v bar equal to delta x upon delta t is equal to x2 minus x1 upon t2 minus t1. Here delta x is the displacement, which is x2 minus x1, and delta t is the time interval, which is t2 minus t1. The bar over the symbol v denotes the average of the quantity velocity. Now remember, average velocity it is a vector quantity, so it can be positive or negative or 0. Now you can also find out the average velocity of an object in a time interval from the graph as well. The graph between x and t is drawn here. Suppose P1 and P2 are any 2 points on the graph corresponding to time T1 and T2, then the slope of the chord P1 P2 it will give you the average velocity during the time interval T2 minus T1. Next term which we have to discuss is average speed. Average speed it is equal to total path length divided by the total time. It is always positive. It is a scalar quantity. Next topic is instantaneous velocity. It is the velocity of an object at a particular instant of time, and it is equal to average velocity when time interval approaches to 0. So we have written here v equal to limit delta t tends to 0 delta x upon delta t. In the language of calculus this will become dx by dt. So v equal to dx by dt is the instantaneous velocity. Now we can also find it from the graph. Suppose there is a point P on the curve corresponding to any time t. The instantaneous velocity at this instant it will be the slope of the tangent at P. Next topic is instantaneous speed. It is the magnitude of instantaneous velocity.